Welcome back. We've now covered Python syntax, some basics about Jupyter Notebooks, and the basic outlines of what you can do with pandas. Let's dive now into additional features you can do in pandas that are more advanced. These features are like the more advanced features in Excel, but Python can even go beyond that. We're talking about things like complex pivot tables, aggregations, cross tabulations, and structuring the data like melting. So let's get started. As we talked about before, the first thing we need to do is to tell Python what we're going to do, because you can do so many different kinds of things with Python. So we'll start by importing pandas as PD, or standard alias, and importing matplotlib.pyplot as PLT. Those are standard every time we start a notebook. These next two lines are kind of optional. It just helps control the way that the output from pandas is presented to us when we look at things like the output of a data frame. And the matplotlib inline is required since we're using a Jupyter notebook and we want to see the plots show up here in the notebook. So I'll shift enter to execute this cell. We talked about in the first lesson that you can add two things together, like two numbers, and get a third number. You can also add two strings together, or concatenate two strings. So here we're going to have a string for data, and we're going to save that as the variable directory, and we have a string here for the name of our file. We'll save that for file name. And just by doing the plus here, we're going to add one piece of the string to the other to create a third string. So our new string that we've created is data/sales_fake.csv. Now we need to read that data into Python, and we'll do that using pandas again. So we want to create an object called df for data frame, and we'll say pd.read_csv and path. That's where our data is held. And here we're just going to take a look at the top lines, so we'll do head. So we have imported our data, saved it as the object df, and now we can see the output of our data here. Perfect. Let's go into how we can now manipulate the data, slice it, and look at different components of it. These next two cells do the same thing we just did, so we can run them again, import the data, and print out the head. All right, so the different observations or rows in the data frame can be called upon by their index number. So if we do the data frame and the method LOC with brackets, then we can pull out the index here for the third item. So if we do that, we see the values that are associated here with 3. So you can see this information is the exact same as this information here with index 3. We can also do a beginning to end. So this is going to start with 1 and go up 2 but not include 3. It did include 3. So there we go. We can also look at the data type and see how these are stored. So our ID is an integer, that's 1 for everything. Our units and ops are floats, we know that. But these ones in the middle are more interesting. So these two are actually dates. And right now they're not being treated like dates, they're being treated like strings, which means that we can't do things together with them. So if you have a date, you can do something like add 5 days to a date, or subtract this date from that date to count how many days are between the two dates, so duration of time. We need to cast these two columns as datetime objects. So we did this in the last lesson, and we'll do it here. So the two columns we want to change are order day and order week. We'll do a simple loop that's going to take each of them from this list and change it into a datetime object and then save it back to itself. Now, when we look at the data type, we can see that the order day and the order week have been changed from object here to datetime. Right? So now we've got datetime objects that we can manipulate using things like adding time or subtracting time. The other thing that's useful to do with datetime objects is to set it as the index. If the index is a datetime object, then we can do time series plots really easily. Pandas knows how to do that. So let's change our index from just being numbers, 0, 1, 2, 3, and so forth, to the date. So now our index is the order day. Perfect. Now that we have set the index as an order day, we can do the same thing we did before by calling the index. So earlier we called the index row 3. That's not particularly meaningful. We have to know that the third thing was what we wanted. Now we can call it by date. That's much more meaningful. So we can pull out the values on a specific date. So this is January 15th. We can also do a range of dates. So between February 15th and February 20th. Or if we don't include a specific day, we can just do the entire month. So with this, we'll get the top 5 in order, but that meet these different criteria. Okay, so that's the things on January 15th. This is between the 15th and the 20th, and these are things in the month of July. So now we're able to slice and start to get more meaningful bits of the data that we might want to analyze. We can also resample the data by quarter, so resample Q for quarter, or resample by month, M, and then we can sum these up. There we go. So we can get the quarterly summations and the monthly summations. Nice, simple, easy to do. There are some exercises here that you can go through, and I will leave those so you have a chance to go through and try those out. Let's go on now to aggregations and groupbys. So when we do data analysis, sometimes we want to see how different groups go together. And when we're looking at sales data, maybe there are different components of things that go together that make sense logically in the sales. So we might want to look at the units and the ops of the different product families. So there are 4 product families, and what we can do is say, I want to see the data broken up by product family. So take the product family and use those as my groups, and for my columns I want units and ops. The way that I want those values to be presented is the sum of all of the units, all of the ops for that product family. Right? So for the entire data set, all of the things that are consumables add up to this. In units, all the things that are hard lines add up to this units. So this is a way of getting an aggregation based on my 4 product family categories. This statement here would be the same as the SQL statement here. That's going to sum units and sum ops and then group by product family. We're doing here the method of sum. That's a method that we get from pandas. But we can also do other things that might be useful. So instead of just summation, we might want to do aggregation by count. So here, instead of using .sum, we're going to use .aggregate. I've got by count. So this gives us the count of these. We can also change this to sum and get the same information that we got before. .aggregate gives us a little bit more flexibility. Okay, so we now looked at things by product family, and we were able to do some summations there. But what if you wanted to do a bunch of things in a row? And this is an area where Python really shines, because all of the things that you're going to be doing, all these transforms, are very explicit. So we can do a group by, here by GL, to different kind of business lines. These are things that we want to group, resample up to a quarterly level, to the sum, and just give me back the top 12 records, because there are a whole lot of these GLs. So let's just look at the top 3. It says our quarters through 12 here. Right, so I've created a new data frame, GL by quarter, that now has this information. And now that we have it organized like this, we can use that for additional analysis. Or maybe we want to put this into a visualization tool like QuickSight or Tableau or something else. Something else we can do here is we can do more than just sum. We can do multiple things. So if you look here at aggregations, this is a dictionary that we're creating. We're creating a dictionary where we have a key of units, and the value is this list of sum and mean, and we have a key of ops with the value of min and max. We're going to pass that dictionary in here. So this whole thing is going to get put as a dictionary here. So group by these columns and aggregate by this dictionary. Now we have a multi-tiered, multi-level index on this data frame. So units for sum, units mean, ops min, ops max. So we're starting to see a lot of additional information in our data set that can be meaningful and help us drive business decisions. So far, each of these have been kind of a one-off analysis, so just kind of typing things in. We could do the same thing if we had these calculations to do repeatedly by making a function. So like we talked about in an earlier session, we can use def to define a function. We'll define a function that summarizes our data, and it's going to take in 3 arguments. We will give it the data frame, the columns of interest, and the aggregation function. So when we do that here, we can accomplish kind of the same thing we did here, but instead of, now that we've declared a function, we can do this over and over again, and it will be easier and more consistent. Groupby is one way of being able to kind of pivot the data. You can also use an explicit pivot table method in Pandas, which will give you the same kind of thing that you can get in a pivot table from Excel. It's a little tricky getting started with the order of this. In Excel, you get a little drag and drop interface where you can pick different things and see how that creates your pivot table. So with Pandas and Python, you don't have that interface, but with some experience and looking at the documentation for pivot tables, this does all make sense. So we'll start by declaring that the data we want to use is data frame, the index we want to use is our data frame index, the columns we want are the product family, there are 4 of those, the values will be units, and the aggregation function we want to do is sum. Take a look at that. So the index here is by day, so this is the sum by day. Right. A nice feature of this, doing it like this, so we've now set our index by date, and we can turn this into a time series plot. So we can take something like the mean or media here, and dot plot, and get a plot, time series plot of the units, because we're looking at here the sum of the units over time. So we can kind of mess up your columns here, so we can just kind of undo that, what happened to the columns, column names. All right, so let's take a look again at our pivot. So we've removed the index, so it's now back to being a regular column, and it automatically gave us back an index. So we can start at 0 and go to the end. So what the pivot table has done is spread things out in what we would call a wide format. And with melt, we can take all of that and put it into a what's called a long format. So here you can see the same information, but it's just been reoriented. In this, right now we see the tail. I'll add a new one here. head 20. So this is the format that Tableau would be expecting if it was doing an analysis of time series data. This is the way that Tableau prefers the data to be formatted. So it can be really useful to do something like this, to go into Python to do that reformatting before you go into a visualization tool, because the visualization tools are not as strong with the reformatting of the data. So you can format it here, and if you have a certain way that you know that you want the data to be formatted, you can set up the Python so you can just take your new data set and do these transforms. And then with AWS, you can use Lambda to take data, automatically apply the transforms, and have that data ready for your visualization downstream. So there's a couple of extra things you can do here, more examples for you to play around with. A final step here, as we're talking about some more intermediate steps, is we can take one data set and we can merge it with another data set. That's a very common thing that you would do in SQL. It's not terribly easy to do in Excel, but you can. So here we're going to get some information about holidays and the dates that they happened in 2017. So all these different holidays. You can see this kind of messed up. It thought that the name of the column was the state and the name was New Year's, and those are actually not column names. So we can avoid that by telling it, when we bring in the data, that the header, so that would be the column names, is not provided, there is none. And names would be the names of the columns that we want to declare. So date and holiday. Let's run this again. Now we've got date and holiday, which is much better than this. And we make sure that we keep this here. All right, so now we can cast these dates as datetime objects and set the index to be the date. And now we can use this method from pandas to merge the two things. We got a data frame, original df, our holiday df, and since both of them are indexed on date, we can join them together very easily. So we'll go through this, and now they have been joined together. So this is the holiday for New Year's. Right? In our next part, we will apply these same techniques to a real data set and do some more interesting analysis of how that works. Thanks.